Use a ruler, a pencil, and a pair of compasses only. Construct the triangle NLM, in which LM is equal to 12 centimeters. Angle MLN is equal to 30 degrees, and angle LMN is equal to 90 degrees. Now, just randomly, this problem might seem to be somewhat of a puzzle that needs to be unraveled. However, if we follow the instructions of the examiners in the order that it is given, then it is not such a puzzle. And as a matter of fact, the entire constructs might be shown to be quite simple. Our first step will be to draw the line segment LM. That we will do according to the statement of the problem, because LM is equal to 12 centimeters is given first. So draw the line segment LM, which is equal to 12 centimeters, after which we will construct the 30 degrees angle. In the meantime, be aware that the little blue triangle represents the point of the pencil. The point of the pencil is represented by the little blue triangle, and the little red dot represents the point of the compass, and you will be reminded during the entire construction process. So there is our ruler, and what will we do first? Draw the line segment LM 12 centimeters. In drawing the line segment 12 centimeters long, we do not begin at the edge of the ruler. Instead, we begin at the 0 centimeter mark and continue to the 12 centimeter mark. Students generally will just take the ruler up and just draw from the edge of the ruler to where their destination is. But that's not the right thing to do. We need to begin at the 0 centimeter mark and continue to the 12 centimeter mark. Let's go. So from the 0 centimeter mark to the 12 centimeter mark. Notice that we are not using the centimeter edge of the ruler. We are using the millimeter, but that doesn't complicate things at all, because we know that 10 millimeters equal to a centimeter, and that is why we have that going up by 10 each time. That's not anything difficult for us to understand or to make use of. So there we have our line segment 12 centimeters long. That is the line segment LM. LM is 12 centimeters long, so we have LM labeled there. On the next slide, the 30 degrees angle will be constructed by bisecting a 60 degrees angle, and that is how it is done according to the requirements of the syllabus. We are not, in this particular case, allowed to use a protractor. So we need to know how to do our constructs in order that our angle will be accurate without the use of a protractor. In this particular case, we will make use of the whole concept of constructing a 60 degrees angle and bisecting it to give us that 30 degrees angle. The constructs for the 60 degrees angle will be there, but the angle will not be shown. Right, so we will have the frame or the skeleton of the 60 degrees angle shown, but we will not have, in the end, we will not have the angle in its entirety. For the construction of the 60 degrees angle, once your compass is set, you should not adjust it. Once your compass is set, do not adjust it. The entire process on this slide should be carried out without adjusting the pair of compasses. So we will not adjust the pair of compasses. As a sketch, we need to understand that your 60 degrees angle is constructed on the basis that an equilateral triangle has 3 equal sides and therefore 3 equal angles of 60 degrees. And that is why for the entire process the compass should not be adjusted, because what we do in constructing a 60 degrees angle is create the frame of an equilateral triangle. And that is why we can have the 60 degrees angle at our leisure. So let us construct the 60 degrees angle at L. Place the compass point at L. Did we do that? I think we have done that already. The compass point is already at L, and your compass point is your little red dot. Place the compass point at L and make 2 arcs as shown. When the arcs are going to be drawn, you will see the little blue triangle which represents the point of the pencil. Let's go. So there we have your pencil, one arc and the other. So that is how we do it, which means that the distance from here to anywhere touching this arc and the distance from here to here will be equal. So this distance touching the arc anywhere and this distance, they are equal, and that is why we should not adjust our compass. Place the point of the compass at the point of intersection of the line segment LM, the point of intersection of the line segment LM, and the arc, the intersection, the arc, and the line segment LM. That point we will put our compass point right there, and we make another arc. What that causes is that we have this distance equal to any distance touching this arc, and we are going to put the compass point here. Now we have it here. The entire process on this slide should be carried out without adjusting the compass, which means that when we put the compass point here and make another arc, what will happen? It means that the distance from here to here is equal to the distance from here to here, and is equal to the distance from here to here. And that means what we have there is the frame of an equilateral triangle. Therefore, if we just draw a line here, we are guaranteed to have a 60 degrees angle, and that is what we are going to do for the time being, because we are not going to keep that 60 degrees angle line in our construct. Complete the 60 degrees angle by a pale construction line segment that goes from L through the point of intersection of the 2 arcs. So 60 degrees angle, just draw line segment from L through the intersection of the 2 arcs, and that is our line segment, and this angle will turn out to be 60 degrees. And please take note that while I am constructing for the CXC examiners, I am not writing in the figures. So we have LM 12 centimeters. I am not going to say that is 12 centimeters. The angle 60 degrees, I am not going to say that the angle is 60 degrees. We will complete the construction of the 30 degrees angle by bisecting the 60 degrees angle. The line that completes the 60 degrees angle may not be necessary. It is not necessary. The symmetry that is necessary to bisect the angle has been initiated by the first 2 arcs that were drawn with the compass point at L. So we do not need this line, because the symmetry required to construct the 30 degrees angle, or required to bisect the 60 degrees angle, was initiated by having the intersection of those 2 arcs, and of course having this arc crossing this line. So that symmetry is initiated by this point and that point, and we therefore do not need to have that line. We do not usually include unnecessary lines and arcs in our construction, because you will see by the end of the exercise that we will have a lovely mixture of arcs on the diagram. So anything that is not necessary to be placed there should not really be placed there. And of course, those should not be given any consideration. So we should eliminate those or just don't include them at all. So that line is not necessary. We just place it there to show you that it is actually 60 degrees, although we didn't measure or anything, but to show that the 60 degrees angle is drawn. But it should not have been drawn in actuality or in the examination, because it is not necessary. To complete the symmetry required for the bisection of the angle, we have this point and that point, and all that is necessary. We may complete the symmetry that is necessary to bisect the angle by placing the compass point at the point of intersection of the two arcs that complete the 60 degrees angle and making an arc as shown. So our first move is to place the compass point at the point of intersection of those two arcs and make another arc. Also, without adjusting the pair of compasses, we will place the compass point here, move the compass point to the point of intersection of the arc and the line segment LM, and make the final arc as shown. The compass point will be placed here, and another arc will be drawn to cross this one, which will complete the symmetry necessary to bisect the 60 degrees angle and therefore construct the 30 degrees angle. The line that goes from the vertex at L to the point of intersection of the final arcs will bisect the 60 degrees angle. Well, there's no vertex there, provided that the other line remained. Oh, yes, so it would have been a vertex if the other line remained. But the other line is not there. So if the other line remained, then there would be a vertex here. And, of course, there is where you will put the point of the pencil and complete the 30 degrees angle by drawing the line all the way through there. So the angle formed is therefore equal to 30 degrees. There we have it. But in our examination, we should not label any angle and any line unless it is a requirement of the examiner. We just do the construct as required, and we can label the vertices, but we should not include the numerical values unless the examiners require that. So that is why we eliminate that 30 degrees. From there, angle LMN is equal to 90 degrees. As usual, the middle letter, which is M on this occasion, is the label of the point where the angle is located. We will therefore proceed to construct the 90 degrees angle at M. So the 90 degrees angle will be located at M, and we will proceed to construct that 90 degrees angle at M. What do we do? First, we will begin the construct by extending the line segment at M. So there we have M. Extend that line segment. Very nice. What do we do next? Place the compass point at M and make a semicircular arc as shown. Well, it is not shown, but as will be shown. So the compass point, which is your red dot, is placed at M. Do not forget, your red dot is the compass point. The pencil, the point of the pencil, you will see in a short while to be the little blue triangle, and we will draw the arc as shown. So there's your arc, very smooth and semicircular. What do we do next? Place the compass point at the point of intersection of the pale construction line and the semicircular arc. Pale construction line and the semicircular arc, and make an arc as shown. So, point of intersection of the semicircular arc and pale construction line is right there. So our compass point should be placed right there. However, it is placed on the other side. Eventually, we will place the compass point there and make the other arc. I think that I'm just wrong-footed on this occasion by, having the points from which we will draw the arc exchanged. But let's go on, nonetheless, draw the arc, because we will eventually have to go there and do it. So we'll go to the other one, move the point of the compass to the point of intersection of the line and the semicircular arc, and make another arc as shown. So what happened on this occasion is that, as a matter of fact, we were wrong-footed. So we exchange the points from which we should draw the arc, but that should not affect the construct. So we'll place the compass point there and make our other semicircular arc like that. So it doesn't matter which one we choose to use first, but we need to place it here and we need to place it there. So anyone will work. Then place the point of the compass at the point of intersection of one of the small arcs. That is one of the small arcs, point of intersection of one of the small arcs. Anyone. This time they cannot wrong-foot me, because I am sure that I am not going to say which one. And anyone will work, and then we move to the other one. Place the point of the compass at the point of intersection of one of the small arcs and the semicircular arc, and make an arc as shown. So we have one of the small arcs, anyone, and the semicircular arc. We're going to place the compass point, the red dot, at one of those points of intersection of small arc and semicircular arc. Then we will make another arc. And what do you imagine that we will change over? Move the point of the compass to the other point of intersection of the other small arc and the semicircular arc, and make an arc as shown. There we have the other arc also. In constructing that 90 degrees angle, it is not confusing, because we are maintaining a symmetry. So first of all, after drawing this pale construction line, we draw the semicircular arc. What next? Compass point place here, we make another arc. Compass point place here, we make another arc. Then we put the compass point here, make another arc, put the compass point there, make another arc. And we see that everything is being done in order. So we do it in pair after the first, which is the semicircular arc. So we do here and here. Then we do here and there. And that's all there is to it. So it might look like a whole heap that is like a code or a horrible puzzle, but in fact it is very simple. What do we do next? Finish the 90 degrees angle. Draw the line that goes from the final pair of arcs to the point. The line will form a perpendicular. Draw the line that goes from the final pair of arcs to the point. The line will form a perpendicular. So there we go. So we have here perpendicular right here. So it goes from here, it goes straight through the point of intersection of the final pair of arcs. And that is our 90 degrees construct completed. We may now complete the triangle by brightening the line segments from L and from M, but we need not go beyond their point of intersection. Brighten this part, brighten this one, but since we are completing a triangle, we do not need to go beyond this point of intersection of the two line segments. Let's draw those two lines. We have your triangle completed with your 30 degrees angle, your 90 degrees angle, and no doubt your 12 centimeter line segment. So their point of intersection should be labeled as N because we were required to construct triangle NLM. We have L and M, we need N. There it is. The triangle is constructed and all construction lines are shown as required by the statement of the problem. We have finished the entire construct. All construction lines are shown, and we will do well not to label the triangle with the angles required. For a very good reason. We don't want to put a figure on the diagram. Then if the diagram is not 100% accurate, the figures might be a little bit different from the requirement of the statement of the problem, and we might lose marks for that. So if we just leave it alone, the examiner might not check it at all. But as a matter of fact, they don't usually do that. They will look at it, look at all of your construction lines, see that they are relevant to the entire construct, and as long as they are, then we know that we have full marks for the problem. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.